Infrastructure for electric vehicles, extension instead of security, and we are Pink Dispatcher and Kati.
Dafür, dass die KI uns vielleicht umsonst dahin fährt, wo wir wollen.
And okay,
eine Runde Applaus.
Please a big welcome and a warm hand for Matthias Dahlheimer. He's talking about electric vehicle charging infrastructure. Thank you very much. I don't know how you feel, but this year was a year where electric vehicles suddenly became sexy. This is maybe because of Tesla and whatever you think about Tesla, but they did it to get the electric car from the ecological corner and make it into something that you want to have. And you can see from the new car registration numbers. And here's the statistics for new registrations from the German registration office. And it's only for electric vehicles. So up to 2010, there's not really much happening at all. There's no really attractive cars. And now suddenly, 2010, there's a small increase. And last year, suddenly the new registrations doubled. And that means electromobility has arrived somehow and has matured in a way that it works in practice. And of course, you can see that in the new registration numbers. And at the same time, the charging networks are growing. And of course, with an electric vehicle on a long trip, you need to go to a public charging point and see that you have many of these points along your route, and there are dictionaries for that which show growing numbers. This is a map from New Motion, and in Berlin they have a growth of 3,780%. And so the charging events, how many times people charge their car on a public point. And of course there's the question, if there's an increase in electric mobility and the charging networks grow and there are big growths in that, and how does the growth work? Is that sustainable? And are there security vulnerabilities maybe? How does it work? Does it work at all? And that's what I'm going to talk about today. And I think that only very few of you have already charged an electric vehicle, so here's the small film, and you take out your charging cable and plug it into the charging point, and this is from Innogy in Kaiserslautern, and I turn on my electric vehicle, and then I can connect a consumer. And of course, this Waffle DAO is really nasty. Don't use it. And in the end, such a charging point is just a plug, just an outlet. And I'm not talking exactly how this charging technology with AC charging works, or in general. If you're interested in that, on this URL there's more documentation, and you can find instructions how to build this adapter. And today there are 3 ways to charge an electric vehicle. That's AC, alternating current, or 3-phase current, and that's what I got from the charging point. And you can see here there's a triple charging point in Kaiserslautern, and the wire that goes to the side to the car, that's the standard alternating current charging. There are 2 other ways. That's direct current, that's Shademo from the Japanese, and that's a charging mode where the car communicates with the charging point over the CAN bus. And the DC charging is the advantage is that you don't need to have the alternator, but you can leave it in the charging station, and so there can be a big alternator, even a heavy one can be in the charging point, and the cars share in that device. And it also means that the charging point needs to communicate to the battery, and that goes over the CAN bus. And that's Shademo, the Japanese variant, and the German car industry has a different standard. And well, they made up and it's called CCS. It's combined charging system, and there's a power line communication between the car and the charging point, and they both talk about IPv6. And today I'm not really talking about DC. What I do today is about AC, and I have 2 charging points here. And the reason is simply they are cheaper, and such a triple charger from ABB, it's about 30,000 euros, and that's the equipment I don't really have available, so I have these relatively small charging points that I brought along today. Another word for my car adapter. This is this one here. It's on one side, there's the Type 2 plug, and that's really a 3-phase current plug with some communication, and in the end it's really just 3-phase current. And in the middle is a little circuitry in this box. And why do you need that? And if you go to a charging point and connect your car to that, and you have the problem that there's a protection conductor isn't there because your car is on rubber tires, is insulated from the earth, so all the electric protection measures, such as residual current protection, doesn't work. And so it's always grounded via the charging point, and the charging point always checks the grounding. So there's a protection conductor surveillance, and there's a small charging control system, and the charging point can tell the car, please don't draw more than such and such amperes, otherwise I'll shut you down. And as has always been shown in the films, I really only use 2 switches. One is this one from Autodar. It's not really in the car, it's always on in reality in the car, but in my test box it has been added so I can separate the car from the charging point without undoing the plug. And the second is the charging request. With that switch, the car can say to the charging point, I need current, please turn it on, or my batteries are too warm, I need a break, please turn off the charging current. And that's all that happens. And the entire thing is described under this URL, and please build it yourself. It's a very simple analog circuitry, but always know that you have 3-phase current up to 380 amps, and it's very dangerous and can kill you, and it hurts a lot, and you're talking to someone who knows about these things. So why am I interested in this? I'm working at the Fraunhofer Institute for Technical and Economic Mathematics in Kaiserslautern, and we decided on this center to make a charging point for employees here. And this looks like a carport, and there are 12 charging points, and employees can charge their car there. And this seems to work in the civil service. We need some way for making the bills to the employees so that they can pay, and we need some infrastructure and process for that. And if you talk about billing for electromobility, then you very quickly arrive at this protocol. That's the Open Charge Point protocol. And it's a protocol that originally has been used in all public charging points. Really, it regulates the communication between a management and billing backend on one side and the charging point on the other side. And the most charging points, there's the protocol version 1.5. It's based on HTTP and XML, and it's relatively old. It's from 2012, and there are successors to that, but they are not really in the charging point. They haven't really been implemented, so this is currently the state of the art. So how does it work? I started reading this protocol specification, and for example, when starting a charging process and want to begin, this following happens. The charging point, that's my charging point, my box, and there's the central system, that's the management and billing backend working in the background. And I go there with a charging token, and what's what's that? I'll tell you right away. And now there's the charging point, sends the authorized request to the central system. The central system looks at it and says, okay, he's entitled to charge. And when the charging process starts and the car starts drawing current, there's a second message that's action request, and it needs the charging token again, and the counter value from the measurement device in the charging point is transmitted, and that's how it works. And if you look at the authorizing request, we find that it's from the whistle schema, and the authorized request is just a sequence with one element, and that's the ID tag, and this tag is used exactly once and has the type ID token. So good, so far so good. And if you look at this ID token, you find that, okay, this is just a string with a length of 20. And it's about 20 minutes thinking about it and reading in it was enough to find that that's really just not what I expect of a billing solution. I had expected some signature and some challenge back and forth and some negotiations and something, at least something where both sides, the backend and the charging token, do something and negotiate something. But this doesn't happen. It's simply a string which is transmitted, and if the string has the correct value, then I can get current. So I started looking at these charging tokens in detail. These are two or several from two companies. One is from New Motion. It's nice because New Motions just sends you 5 tokens if you fill in a web form. And there are 2 variants. One is a key fob and one is a charging card. And the thing you see in the foreground, that's my charging card from the municipality of Kaiserslautern, and they have a network called Ladeinfrastruktur and bought it from there. If you have from your municipality, some of them, a card like that, it's probably from the Ladeinfrastruktur, because almost all cities use that.
Ja, ein bisschen Werkzeug. Was habe ich benutzt, um mir diese Karten mal anzugucken? Der Klassiker ist der Proxmark 3. So das Schweizer Werkzeug, Schweizer Taschenmesser, um sich mit NFC und RFID-Karte zu beschäftigen. Hier in einer etwas billigeren Variante, die nicht den vollen Funktionsumfang hat, aber vollkommen ausreichend und eigentlich ein cooles Werkzeug. Was auch extrem cool ist dieser Chameleon Mini. Den habe ich benutzt, um Ladekarte zu simulieren. Das kommt aber erst später. Im Endeffekt sind das einfach Lesegeräte und Simulatoren für NFC-Karte.
To simulate an NFC card.
Ja, gucken wir doch mal auf so eine Ladekarte drauf.
What is an NFC card? What
in
is a
meinem
charging
Proxmark
card?
3 tippe ich einfach mal HF Search ein, sprich, zeig mir mal, was du über diese Karte, die da gerade drauf liegt, weißt. Und dann sehe ich halt zunächst, okay, da gibt es eine UID, die habe ich jetzt im Folgenden auf Bad gesetzt. Da steht normalerweise irgendeine hexadezimale Nummer. Das ist quasi die Ladekartennummer. Ich wollte mit realen Ladekarten da arbeiten. Insofern immer, wenn ihr Bad seht, das ist dann eigentlich die Nummer eurer Ladekarte. Und ich denke, einige, die sich mit NFC-Technik beschäftigen, haben jetzt schon geschmunzelt, weil der Kartentyp ist eine MyFair Classic. Eine MyFair Classic klingelt vielleicht bei euch. Das ist ein Kartentyp, wo es vor ziemlich genau 10 Jahren schon mal einen Vortrag auf dem Kongress gab von Carsten Null und Henrik Plötz, die gezeigt haben, dass die Krypto-Implementierung, die proprietäre Krypto-Implementierung auf dieser NFC-Karte einfach kaputt ist. Ja, so von 2007 bis 2010 gab es mehrere Publikationen von unterschiedlichen Leuten, die immer wieder ein bisschen mehr gefunden haben. Und heute ist es eigentlich trivial, so eine MyFair Classic komplett auszulesen oder zu simulieren. Ganz einfach, weil die Krypto-Implementierung auf dem Ding kaputt ist. Ich habe dann mal so eine Ladekarte ausgelesen und wie ihr seht, seht ihr nichts. Hier dieser große rote Kasten, das ist einer der Blöcke, die auf dieser Ladekarte vorhanden sind. Da stehen nur Nullen drin, bis auf in der 4. Zeile. Das sind die Default-Keys und die Default-Berechtigungen. Ja, also das ist das, was ich auf einer leeren Karte einfach so vorfinde. Das Einzige, wo sich Ladekarte drin unterscheide, ist die UID. Da oben wieder kleines rotes Rechteck, da
the
steht bad
small
drin.
rectangle up there,
Das ist
it's
der
saying
einzige
bad.
Unterschied und alles, was in
This is the
dieser
only
Zeile
difference,
sonst so kommt,
and everything
das sind
around it is just manufacturing IDs and some bits we don't actually need and we can ignore
Das
it.
heißt, so eine Ladekarte ist leer.
Such a charging
und
card
es
is
wird
empty.
Als Merkmal, Ladekarte zu unterscheiden,
And
einfach nur
to
die
tell them
Kartennummer
apart, you
verwendet.
use the card number,
Das ist jetzt
basically.
relativ seltsam,
So
weil
this is kind of strange because
diese Kartennummer
well,
dient
this
eigentlich
card
einem ganz
number
anderen Zweck.
is
Nämlich,
used
wenn ihr
to
euer Portemonnaie in der Mensa auf den Mensa-Kartenleser
for example,
legt,
if you put
sind da
your
vielleicht mehrere
wallet
NFC-Karten drin, die dann entsprechend
your
auch
wallet
antworten würde, wenn
onto
so
a
ein Leser
reader,
fragt, was ist denn
there
hier?
might be more cards
Dafür
than one
gibt's
in
halt
your
in dieser
wallet.
ISO-Norm die
So
sogenannte
this
Anti-Collision
ISO
Loop,
norm,
die
it
sorgt
has this
dafür, dass
so-called
ich halt,
anti-collision loop,
oder dass ein Kartenleser
so that a card reader
verschiedene Karten, die da liegen, enumerieren kann und
can
dann sagen
number
kann,
all
okay,
these
liebe Karte
cards
5,
and
ich
can
will jetzt
say,
nur
well,
mit dir
card
reden
5,
und alle
I
anderen
want to
halten
talk
jetzt
to
bitte
you and
einfach
all the others have
Ich
to
habe
be
hier mal
quiet.
NFC-List, das ist ein
So
anderes
this is
Werkzeug,
an NFC-List,
benutzt,
this is
mal
a different
zwei,
tool I
Karten
wanted to
parallel
use
auszulesen
to
und das
read the
funktioniert
card.
gut. Die
This
erste
works
hat
pretty good.
Die erste hat die UID
Well,
EB,
the
EC,
first one
E5,
has the following
und die
UDID,
zweite, das ist wieder meine
and the
Bad
second
Card.
one is still my bad card.
Also, ja, dafür ist es eigentlich gedacht.
So that's what it's made for,
Um das nochmal
basically.
zusammenzufassen.
So to summarize this,
Das Managementprotokoll
the management protocol of the charging infrastructure
basiert darauf,
is
dass
based on
Authentifizierung auf einem String der Länge 20 stattfindet.
authentication on a string
Das
with 20
einzige
characters.
Merkmal, wo sich Ladekarte
The
unterscheidet,
only thing that
ist ein
differs
öffentlich auslesbares,
is a publicly
nicht mit Krypto
readable,
versehenes Merkmal,
not
was jeder Kartenleser
non-crypto
an jeder Stelle einfach auslesen kann.
that you can
Und
read
genau diese
anywhere.
Nummer
And this
wird quasi
number
dazu benutzt,
is used
um
to
euren Ladevorgang einem Abrechnungskonto zuzuordnen.
connect your charging process to an
schlecht.
account. Well, this is pretty bad, in my opinion.
Ich habe dann einfach mal eine
So,
Ladekarte kopiert.
I just copied a
Das ist meine
charging
eigene.
card.
Ich
This
hab
is
auf
my own
meine
one.
Rechnung, geladen.
I charged on my
Dazu habe
account.
ich hier mein Chameleon Mini
So I
benutzt.
used the Chameleon
Dem
Mini
sag ich
for
jetzt
this
einfach
to
in
tell
dieser
it,
Kommandozeile, hey,
well,
tu mal so, als wärst
well,
du eine MyFair Classic
just
1K.
make sure
Benutze die UID
to disguise
das war
yourself
dann
as
meine
this
reale
card and
Ladekartennummer,
with this
von
ID,
NewMotion,
the bad
und
card,
hab das da drauf geflasht
and I just
und,
flashed
wir
it
haben
onto
eine eingebaute
it,
Batterie und damit kann ich
and
jetzt
I have a
zu einer
battery and
Ladestation
just can go to a charging
das
station.
passiert hier dann auch.
And that's
Ich
what's
halte meine
happening
Karte
here.
davor.
I put the card in front of the
Die
reader.
Ladestation fragt, hey, hier
The charging
schließ mal dein
station
Fahrzeug
tells
an.
me,
Das heißt, ich
okay,
steck da
connect your
meinen
car.
Adapter rein,
I plug in my adapter.
Sag dem Auto, okay, tu mal so, als
I
wärst
tell
du
the
da
car
und
to-
fordere Strom an.
I tell the
Die
system to
Ladestation sagt
pretend the
dann
car
auch,
is
jo, ich
there,
red mal mit dem Backend und das
and
sieht gut aus,
the
ich
system
starte den
tells me,
Vorgang.
okay, everything's fine, just
Das heißt, ich
charge.
kann mit trivialem, also das leuchtet grün, ich habe
So
wirklich
this
Strom
is
da rausgekriegt.
charging green. Well,
Das heißt,
yeah.
ich kann mit trivialem
So,
Aufwand eine
With
Ladekarte
pretty
kopieren.
simple measures, I can copy a card.
Vielleicht kann man auch Ladekarte Rate, da habe ich so
And
eine
maybe you can
Hypothese,
even
weil
guess
einfach
charging
die
cards because
Tokennummern
the
von 5
token numbers
Token
of
sich nur
five
in 2 Bytes
five
unterschieden
subsequent
haben, aber
cards are just differing in a few
ist
things.
etwas, was ich nicht ausprobiert habe.
I haven't tried this, by the way. It's just an hypothesis I have. I can't
gibt
prove
aber
it,
viel einfachere Wege,
but
an
there's
diese Ladekartennummern
pretty
zu kommen.
simple measures to
Einfach
get
nur
these
noch mal, damit
numbers.
es klar ist,
So
ihr braucht nur
just to
diese
make it
Nummer
sure,
und
you
dann
just
könnt ihr
need this
laden.
number so you can charge.
Wo ihr die herbekommt, ist irrelevant.
No matter where you get it from.
Ja, ich kann mir auch mit einem Android-Handy
Well, I
und
can just
einem
use an
30
Android
Cent,
smartphone and a 30 cent
MyFair Classic
China
Tool,
MyFair
kann ich mir
card.
meine Ladekarte einfach
I
selber
can make my
programmieren.
own charging
Das
card,
ist
basically.
kein monetärer Aufwand, man braucht
That's not
dafür
really
nicht unbedingt diesen
expensive.
Chameleon Mini.
And you don't need the Chameleon Mini.
NewMotion hat das korrekt
So,
abgerechnet, etwa einen Monat
NewMotion
später. Man sieht
charged
da,
for this.
Pierre de Presse-Platz in Gensing.
Well, I was in Gensing. There's three charging processes, and I had 15 euro cent because I stayed there for 6 minutes, so I didn't really use power, but I was there.
Das betrifft nicht nur NewMotion.
That doesn't only touch
eigentlich
NewMotion.
fast alle
It
Ladekarten, die es
touches
irgendwie gibt.
all charging
Ich
services
habe
around.
getestet NewMotion,
I tried
BMW
NewMotion,
Charge Now, Ewald,
BMW
das war eine
Charge
Ewald-Ladesäule, die ihr da gerade gesehen habt,
eVault
und Ladekarten
and
von
Ladenetz and
und
charging
von
cards from Ladenetz.
Wenn ihr eine Elektronauten-Ladekarte
So if you
habt
have an
von
Elektronauten
BMW, die haben
card
genau
from-
das gleiche Problem. Ja, ich würde einfach davon ausgehen,
from a
weil
different
in
provider.
den
I would
Protokollen,
just
auch in den
say
Roaming-Protokollen zwischen
that all these
Anbietern
protocols, the
einfach
roaming
nur dieser
protocols,
String als
they just use the string to
Authentifizierungsmerkmal
identify
verwendet wird.
yourself.
Das ist einfach die komplette Industrie.
And that's the
betrifft.
whole industry.
Wenn ihr eine Ladekarte
So
habt,
if you have a charging card somewhere,
ist ja eher schlecht.
well, yeah, that's too bad.
Okay, this month this is not an online procedure. So Ewald only charged me in a batch and communicated them to NewMotion after a month, and maybe you only know after a month that someone misused your charging card, and of course then as electric vehicle driver then you have a problem because you need to challenge the bill. And what does NewMotion say? It's as an example, there's a tweet here, and at no time there was any danger to the public, and we take it seriously. And well, 2 months before I published the first part, I tried to talk to NewMotion and with other charging card issuing companies, and I didn't get beyond customer support. So there's no email security at NewMotion or something like that where someone's reading it who can really evaluate it from a technical standpoint. And so there's a little overview here. We have a charging point, and the charging card, I crossed it out because it has been known bad, and there's a backend from the charging network, from the charging point that is in use currently, and there are other companies, and there's a roaming protocol called OCMI, and they are connected to each other. So just let's look at the OCPP in some more detail. This is a charging point from Hacker, and I have one here. That's what it looks like. It's a little box. It's just a demonstration piece that they lent me. And please don't extrapolate from this cabling from a real one. It's just not about product quality from Haga. But what I like is from the electrical safety standpoint, I quite like it. It's really clean, and it really works very well. So in it they are coming from installation racks, building installation racks. There's a bus bar, and there are clips on it, and there are relays, and there's auxiliary relays, and cable protection switches, and everything. And on the upper part, you don't see the card reader because it's behind the circuit boards. On the right-hand side is the charging regulator. That's about safety checks and electrical safety, and everything works. And in the end, turns on the charging current. On the left side, you can see a little ARM-based Linux system. There's some Python stack on there, and communicates to the outside world over the OCPP protocol. And on the lower left, there's a network cable, and that's normally the connection to my mobile modem built into the charging point. And you can see it's a modular system, and that's because the manufacturers, almost all of them, use different hardware variants from their charging points, and some can communicate, and the others don't really need that and simply don't have the communication module. What does it look like? So if I boot the charging point, it's just a simple AC plug. It's just my desktop setup, and an LED lights up, and my OCPP implementation that I wrote for testing purposes. It takes a while, and then there's a boot notification request, and there are various things here. For example, hey, I'm a Haga Witty Park, and I have this firmware revision. And, well, there may be more fields there, but I didn't implement them. And there are 2 status notification requests, because this charging station has 2 charging ports. This is the type 2, and below that is a simple AC plug. And both are in the state available. That simply means if you walk around with your handy app, the smartphone app, you can see if it's in use, or if it's free, that charging point, that's what it's for. So this start of charging, there are 2 requests, 2 messages. authorization and transfer authorization. And we look at that. I plug my electric vehicle into the charging point. It's a bit hard to do that because they are waterproof, and put on my charging card, and my backend receives an authorized request with the ID tag bad. And my backend accepts every card, so it's auto-accepting. That's what it says, because the backend says it's valid. It's a valid token. You can continue. And okay, now it hangs. All right. Ladetoken, charging token, and there's the next message, and this is notification. There's electric vehicle is connected, and availability. The availability in smartphone app would be updated then, and there's startup action request. That's connector ID 1, that's the type 2 plug, and the ID tag bad, which I used in this case. And there's metastart, it's 0. Normally there's a counter value, but in this charging point there's no counter because I don't need that for the demonstrator. Okay, and now I can go there and turn on the current, and if the car says I'd like to get charging current, and then the current is turned on as you would expect. And the problem is at this point, at the point where I looked at the network communication in more detail. And normally, these two communicate charging points with HTTP, unencrypted HTTP. And the argument of the manufacturer is we use a separate APN and nobody can get to it, and we don't need encryption. And well, I could just open up the charging point, and inside the charging point, look at the traffic, at network traffic. It's trivial if you have ngrep or something like that, network grab tool to make a printout and show me the charging tokens and extract them from the network traffic. And that's what you saw just before between charging point and central system. There's a communication goes via HTTP. You can configure it in a way that it does HTTPS, and I simulated that by making a secure tunnel between that and an S tunnel, and I gave it a broken certificate, self-signed certificate, but the charging station said, oh, that's fine, I now do encrypted communication and I'm all secure. And you just need to do a man-in-the-middle attack, and there's really no effective encryption in this system. I just skip this one. It's funny that in a way you can just also do remote control of these things, but I don't really have time for that now. But you find these things on Showdown. And so there's a mobile phone APM. Not everybody implemented that really, but please don't muck with that. If you disable it, someone is really there and can't drive home, and that's really, you have to be careful with that when playing with it. Just say okay, OCPP, just cross it out and look at the charging point itself. So I don't know if you noticed, but if you open it and look what's inside, you will find USB ports everywhere. And on the right side, there's this Hager station. The left side is this K-bar station, K-bar P30, and which really is quite capable. And the USB port is for a service technician and can do a software update or change in configuration. Something like that. Okay, what happens if I put a FAT32 formatted USB stick and it makes a log file, and there's a lot of information on that. So what kind of hardware is running, which revision and things like that. So I put in an empty USB stick and then I have this log file with these contents on it. And I also get the network configuration. And what's even greater, I get the access data and the public endpoint of the OCPP server. So, okay, Yeah, it's really there. Just loosen 2 screws, open it and put in the USB stick, and you have all the information you need. But it gets better. I can edit this file and can put it back, and it is taken over as the new configuration. I have to know how to rename the file. That's the only thing, but that's in the manual, so that's fine. Okay, I just mentioned it. In the end, in 2 minutes, you can read out the charging point completely, look at the configuration, can think about how you can make an attack on the network infrastructure, how you want to, if you want to install a Raspberry Pi in addition, and there are infinite degrees of freedom, and you can't turn it off on this charging point. It's just a feature that is implemented by the manufacturer, and that's just the way it is. With Keba, that's the other one. It works similar in principle. So you can turn off the update of the configuration, but I still can update the software. Also with the USB stick, you create a subdirectory UPD and copy the firmware update file there that you can download from Keba, and copy it there and plug it into the charging point, and the charging point makes a software update, which is very convenient for the service technician. And if you look at this update package, you find that it's just a zip file, and there are files in there which well, you can perhaps modify, and of course I did that, and I plug in my USB stick, and I'll do it live here in parallel. And there are some messages, USB updating. I found a USB stick, and I update the software, and it just unzips the zip file, and there are some scripts in it that are executed. Well, of course, you can have a lot of fun with that. And for example, you could show a message like that, and you can also do that via the UDP interface, just like that, and you can get at those functions in another way. And what happens here is that a script that I wrote is executed, and that's on the local file system. But what you didn't see here, and I hope that worked in the background here, is that a shell popped up. So I have a network connection, and there's a router and a network connection over this network cable to my computer. And it's a Keba 430 with a Keba P30 with a halfway recent Linux. And I'm root. Yes, what else can I say? How did that work? Very easy. As I said, this KEB file is really a zip file. There are some scripts inside. For example, the install.bsh, there's the entry point for the update. It's a bean shell file. It's just some sort of Java shell. I have no idea what it is, but I just modified the existing update scripts. And in this install.bsh, there's a little environment made up there, and I have some tools at my disposal there, and just in the subdirectory I call some other BSH files, and I just have a made up from the Keba files that Keba delivers. There's a reverse shell, and via string concatenation I make my own shell scripts. I write that to the hard disk, and I start it. And the whole update process uses no authentication whatsoever. I told that Keba, and they said, oh, they knew about that hole and they closed it, and I couldn't verify that yet because I got a changed version from that. Haven't gotten that yet. But so if I think that if you find a Keba charging point somewhere, I guess that it might still be vulnerable to this problem. And in the comments of the update packages in this bean shell, I saw that in the future maybe they want to use an encrypted zip file, so maybe it's password protected, but that also means that the password itself has to be stored on the charging point, otherwise it wouldn't be able to check if it's a real update. So I don't know if that plan is really very good, but really it's a Debian-based system, and Debian really uses a solid package management, so you could just use the package management that's already there. So why invent something new? Well, what can I do on the charging point? So this is really the script. It's a PDC display args, and that displays the message on the charging point. It's not very exciting, but there are some other scripts that I change configuration or make other things with the charging point. What's more interesting is, well, what else is stored on user data. And you can, the previous charging tokens from previous drivers have charged there. You can just get it via grep from the log files. They are unencrypted. And so the exploit is quite obvious. I just make a USB stick, put it in the charging point, and as root, something is executed, and I just do my grep file in this bean shell and write back the results from the grep onto the USB stick, unplug it and go away, and maybe I have the last 100 valid charging card numbers in the file. I have to say, I have to loosen 6 screws to get to the USB port. That's not a real problem for someone at night. Within 2 minutes. Much more problematic is a scenario what the charging point owner could do, because he has access to that and can get the charging card numbers by attacks on the charging point and collect the numbers, make an OCPP client, simulating charging processes and simulate charges that actually never happened. So I make for myself an additional income, and as a customer I have a problem that I have to challenge that bill, and someone stole my card number, and what do I do? And I don't want to pay for that. Etc.
Es hört da nicht auf. Es gibt zum Beispiel
But it doesn't stop here.
There's
a method called autocharge from ABB, the fast charge system. They are offering public charging stations, and they want to spread this system. Autocharge works as such as I have a CCS vehicle with a DC charging process, and instead of using a special certification structure from CCS, you're just taking the MAC address of the car as an authentication method.
So the
90s want their access control back. There's no matter where you go in charging infrastructure, there's so many serious issues that is really sad. So let's add this up. Charging cards are broken because they're using a public ID. OCCP is broken because there's no clean handshake between structures. The charging systems I looked at were pretty broken as well. So
ich greife nur Dinge an, die ich wirklich auf meinem Schreibtisch liegen
I just want to talk about things on my desk, so I can't tell you about the quality of the charging compounds. But it would be interesting to do that, basically.
Was sich jetzt so als roter Faden durch die ganze Geschichte zieht, ist,
there's a red herring going through all this. So
schwierig waren, wenn es Fehlerkultur und das Eingestehen
von Fehlern geht. With issues.
Zum einen die Anbieter und Hersteller,
so the providers are telling me, okay, yeah, we have security and everything is fine, and we don't know about abuse, but that might be because there's not too many electric vehicles on the roads, so it's not really a big infrastructure we have yet. On the other hand, if you have the Going Electric Forum, it's special discussion board for users of electric cars. They are telling us, well, everything's fine, everything's good, nothing happened yet, so we don't have to talk about it. That's not really a good way to handle this problem, because this is touching the whole infrastructure. So, but we should say, well, yeah, we have issues and we have to solve them. So that's basically what I want. I bought an electric car. Next year, I want to charge at a charging station easily without having to think about safety, whether someone can steal my card data, whatever. I just want to trust the structure. And I don't have this trust at the moment because there's too many problems and too many conceptual problems that don't only touch the providers but also the whole industry. So let's just do it better. Just get together and talk about this and make it an open source project with a better implementation where all these issues are resolved, basically. Thank you.
Das war wunderbar.
Well, that was great.
Aluhut als Kompliment.
I'll take Aluhut as a compliment. We have 15 minutes for Q&A.
Das heißt,
so that means anyone who has a question, even the internet, there's a few questions there. They can use a microphone, and I'm trying to coordinate everything. Whoever has to leave the room, just go out on the right. And the new feature, the exits on the stage tops, you can actually use them. And they seem to be quite comfortable, by the way. So we're starting with a question from the internet, from the Signal Angel. Yeah. The internet wants to know if you have cared about ISO 15008 and if you know about the security of that.
Unfortunately, I really don't know it in any detail, as I would like, though I would like to. The 15118 is really what's behind the CCS system and is used there. The problem with ISO standard is really that they are very expensive if you want to buy them. And another problem is that neither do I have such an expensive charging point nor an electric vehicle that works with that, but I'd really love to look at it in more detail, yes.
So please, internet, just donate him a Tesla.
Crowdsourcing.
Well, crowdsourcing.
Mike 3 war als erstes da.
Mike 3, please. Hello. I have kind of the same question. The problem is the compatibility to older cars, because the structures were so easy because the cars are so easy. So I guess it might take centuries to remove all the old charging stations. Is there anyone who has talked to you, car makers?
So my subjective impression is that it's just a loose collection of technology, and I have heard through the grapevine that the card numbers were the only thing that we could agree on. Not we thought it was a great solution, but in the future it'll get worse when there are more electric vehicles. There'll be new technologies, and perhaps I have an old car which can't get a new update of the CCS stack, and so can't be charged via DC. And I think it's going to get worse.
Unser Internet.
So internet question. Well, the internet wants to know whether there's a certification from BSI, for example, like power meters.
So there's currently no regulation in this area. There's no no checks and no assessment for security and safety. The Federal Office for Electricity Metering says that we need a certified smart meter gateway in the charging point, but which is so expensive that it wouldn't amortize. So the solution for the charging point, the way they do it is now that you just charge by time and not by current. So that's why I had to pay for new motion for 0 kilowatt hours, but for 6 minutes. And so there's no regulation really, and I don't know that it's in the making.
Der Markt regelt das.
The market will do it.
Microphone 4, please.
Und danke erstmal für den Vortrag.
Thanks for your talk.
Mit den Geräten, die du da jetzt stehen hast, das sind ja im Grunde genommen Demo-Geräte, wenn ich das jetzt richtig verstanden habe. Kann das daher dann jetzt auch sein, dass das fehlende HTTPS und dass die USB-Sticks Sachen einfach nur daher kommen, dass es in den Realimplementationen gar nicht der Fall ist?
It's not happening in a real implementation.
No, this is the real hardware, just in a different box, but it's really production hardware that is used in deployed stations. And this is a station that we bought with Institute, with the Fraunhofer, and this is not demo hardware, it's the real thing.
So I might have misunderstood that because you have shown this, and well, this didn't look as
it's einfach nur, weil es ein separates
reality.
Ist, was
no, just because it's a different box, right? Yeah.
Einmal unser Signal Angel, das Internet.
So the Signal Angel, the Internet.
Also erstmal ein Kommentar.
Well, there's a comment.
Die Ladestation müsste wohl offensichtlich ein Contain Cyber Aufkleber.
You would have to stick a Contain Cyber thing on the box.
Kreuzschlitz oder Philips?
So Philips head or Philips head. So isn't that the same thing?
Kreuzschlitz.
So one is Philips, the other is Philips. I don't know.
Aber es gibt lustige Sets von Vera, da ist alles drin.
So.
Das war einfach.
No, that was easy. Microphone 2, please.
Jo. Hallo. Moin. Ich bin einer der Entwickler von NFC Gate.
I'm one of the developers of NFC Gate.
App, womit man auch
That's
so mit
an Android
NFC
app where you can play around with NFC and IDs and everything. And we are searching for hardware using MyFair Classic. Can we play with your hardware?
Ja, knock yourself out.
Yes, sure. Knock yourself out. Use a public charging point, and they'll expect MyFair Classic. Can we try it on the Congress? Can we try yours on the Congress? Well, with my charging card, talk to me and we'll find a solution. And I don't know if I let you read it, but we'll talk about it.
Nicht, dass die KI uns dann sonst wohin fährt, auf seine Kosten.
Not that AI just drives us somewhere.
The Internet.
Das Internet wird gerne
Well, the Internet wants to know.
Die benutzen ja schon irgendwo
Well,
Linux.
they're actually using Linux.
Je nachdem, wie ihr reden, auch
So,
mit der Custom Hardware.
whatever you
Wie sieht's denn
talk
da aus
about
mit
custom hardware,
müssen die vielleicht irgendwie
what's all
Code
about licenses, and do they have to give you the code?
Frage.
It's a good question, and I really can't tell you now, but I assume that it's based on open source components, and we'd have to take a closer look who's linked to who, and maybe there's GPL licensed components, or well, I don't really know at the moment.
Wunderbar. Die Nummer 3.
Well, number 3, please.
Hallo, ich bin bei einer solcher Projekte beteiligt und kenne das daher ein kleines bisschen tatsächlich auch von der OCHP-Perspektive. Das ist auch ein bisschen abenteuerlich. Zwei Sachen. Einerseits die Eich-Ämter sind ja gerade dabei, eine ganze Menge verschiedene Vorschläge zu machen, mal nicht. Hattest du da schon mal Kontakt?
Giving out ideas how to do it. Did you have any contact to them?
So no, I think that's interesting. We should email and talk about it.
Because it would be the mechanism to make it a little more sensible.
Gleich drüber reden.
Ja,
well, and that's a different thing. I want to talk to you later.
Sanity Check.
Sure, yeah, right.
Einmal die Internetfrage.
Well, an internet question again. The internet wants to know how can charging station users save themselves? What can we do
Naja, also es gibt Anbieter, die sagen,
So
okay, du kannst
some companies say you can use our infrastructure with a smartphone app, but I haven't looked at the smartphone apps, so maybe security-wise they're just as bad. I don't know. But that's one option if you really don't want to use the card, the charging card. But if in doubt, maybe in the worst case you just know after 4 or 6 weeks that your token has been stolen and is used somewhere else. So it's really about how the company handles it, if they cancel the bill or something. There are no experience with that, and there's a lot of uncertainty, and that's not really good for electromobility as a whole.
Mic 2.
Microphone 2, please. Hello.
Is it okay to ask a question?
Sure.
Okay.
And they are asking in English.
From Radboud University in Nijmegen.
I'm from Nijmegen.
We are working with a few Dutch charge companies.
With a few Dutch charging companies.
Thank you for shredding OCPP 1.5.
My pleasure.
Could you also shred 1.6?
Could you also shred 1.6? And have you also already looked at 1.7?
Done yet, but I've seen it.
It's not done yet, but I've seen it.
They've actually
seen
Chapter 1 TLS.
Chapter 1 TLS security requirements and everything, but have you seen that?
I didn't have a look at it. I know that 1.6 is basically 1.5 with a little bit more functionality.
It's just 1.6 is just 1.5 with a little bit in addition with JSON.
With regard to
and 2.0,
I know that it's now
didn't look at it.
Available or publicly in a review process. So I definitely will have.
It's in a review process, but we'll have a look after Congress. Die kriegen dieses.
Mike 4.
Ja, vielen Dank erstmal für den Vortrag. Ich möchte ganz kurz erwähnen, ich war überrascht, dass so viele Leute sich hier doch für schon die ISO 15118 interessieren.
I was surprised that so many people were interested in the ISO 15118. If anybody has any questions about that, I can talk about the security implementation. I worked with standardization for that, and if there are any more questions, I can do that. Yes, and we should talk. Yeah.
Super, danke.
Kommt noch eine Frage aus dem Internet?
Any questions from the internet, Signal Angel?
Da oben.
There's one upstairs. Microphone 6. There's 3 people basically. So, hello in the back.
Okay.
So.
Ich bin im Backend-Bereich involviert.
I'm involved in the backend area.
Einen gewissen Anbieter, der erwähnt wurde.
With a provider that was mentioned.
Es ist genauso schlimm.
It's actually really as bad as you said.
Wir haben das alles schon 2012 mit den Hardware-Anbietern.
We had all this in 2012 with the hardware providers and the customers.
Mit den Hardware-Anbietern und den Kunden besprochen, aber es besteht einfach kein Interesse.
There's no interest in this to make it better.
Ja, dann hoffen wir.
Well, then we hope that the interest will grow with time.
So, also es tut mir leid für die Leute an 5 und 6, aber
I'm sorry for the people at 5 and 6.
Gleich mit dem Matthias nochmal
You can talk to Matthias in person.
Sehr viele interessierte Kunden hier im
There's many interested customers in this room.
Vielen Dank an unseren Speaker.
Thank you to our speaker.
Danke.